All right, hey everybody, welcome to our first class. We are going to talk about evaluating functions today. What you're doing now is to jot down a quick story that describes the graph. So here you have a general graph. I actually erased the x and y axes because I want to leave it open to interpretation as to what your story can be about. So at this point, please pause the video and come up with any story that you can come up with that is true to this graph. All right, so hopefully you've come up with a pretty good story. I'm gonna have you guys share some of that if you so wish during our synchronous session, but let me share with you now what I came up with. So here I have, this graph represents the rainfall during a year in Wakanda. The beginning of the year is the dry season there. Towards the middle months, rainfall picked up, and the latter months comprise the rainy season, and this year was no different. Okay, so yeah, so the x-axis would be time, and then the vertical axis, the y-axis, would be rainfall during that month, or I guess during a day. Units, you don't have to be that precise here, as long as you're consistent with this graph. Okay, but yeah, low rainfall here, more rainfall that picks up, and then gradually a lot of rainfall during these latter months. Okay. Homework for today is a worksheet that I'll post on Google Classroom. So just it'll be 4 questions, and I'll upload solutions also, and we can go over any questions that you have regarding the classwork and the homework during our synchronous session. Okay, let me move on to the lesson for today. So here we have just a quick definition regarding a function. Today's lesson is going to be really quick because you should have learned this in Algebra 2. So hopefully this is a review for you. But let me just dive into the function. By the way, you should, the definition. By the way, you should be copying this down in your notes. So just treat this as a normal in-person class. You should be taking notes because you're gonna have to, study these concepts. And I just find that writing helps you just really absorb the concepts that are being spoken about here. Okay. But yeah, the definition here is a function f is a rule that assigns to each element x in a set A, which we call the domain, but I'll get into that in a later lesson, exactly one element called f of x in a set B. Okay, so a function f is a rule that assigns to each element x in a set A exactly one element called f of x, so x is paired with f of x in a set B, and set B will be the range. Okay. So pause the video here to copy this definition down, and then after that, I'll explain this picture here. All right, so regarding this picture, we have this store in England. You can tell by the pound signs, right? The pound symbol. You might be wondering why I had this picture here. The reason for this is actually an analogy for a function. So anytime you have a store, think of a function. Okay, so store is actually a function as well. Let me preface that by saying it's with regards to price. So anytime you have an item in a store, let's say you have, I believe this is like some kind of cleaning product here. So this cleaning product costs £5, right? Now, it would be crazy if this cleaning product had 2 different prices at the same time. So it wouldn't make any sense if this cleaning product cost £5 and £10 at the same time, right? That would not make any sense. Same thing for a function, right? So one x value, this laundry, or not laundry, this cleaning product here, this x value can only have one y value at a time, right? So one x value has to be paired with one and only one y value, right? However, this same store, the same function, in order for a relation to be a function, the items, it's okay if different items have the same price. So for example, let's say you have an apple and an orange. Those are 2 different x values, right? An apple and an orange, let's say. It's okay if that apple and that orange share the same price of $1, right? So it's okay if the apple costs $1 and the orange costs $1. That's okay, that's fair game, right? So think of a store as a function. That's how I remember it. I remember when I was learning this back at Mystery High School, this is the analogy that stuck with me, and yeah, it works, right? So whenever you see a function, just think of the prices in the store. That will hit, you know, all the qualifications for that relation to be a function. Okay. All right. From there, actually, we're actually gonna talk about the classwork, and which is a worksheet here, and just 4 problems. I'm gonna complete some problems with you in this video, but I'm gonna leave some problems to do on your own. And then during our synchronous session, we'll go over the problems that I leave to you. Okay. Now, I'm actually going to try something new because this is what I plan on doing during asynchronous sessions. So I'm actually going to use the dot cam. I'm at Bronx Science right now, so we have the dot cam here. And let me see if I can share what I see under the dot cam. Okay. All right, there you go. So hopefully you can see this here. All right, there you go. Okay. All right, so I already completed some of the questions. Let me move my chair here. So question number 1, here we have to evaluate the function f of x at x squared plus 3x minus 4 at the following values. So we have f of -2. So f of -2 is -2 squared. So you just plug in, right? So -2 squared plus 3 times -2 minus 4. And then you're going to end up with 4 minus 6 minus 4. Okay. And then 4 minus 4 is 0. So you end up with -6 for part A. For part B, it's f of 0. So 0 squared plus 3 is 0. 3 times 0 minus 4. You're going to end up with -4. Okay, so it's -6, -4 for parts A and B. And then for part C, here we have f of 4. So you just plug in again, as always, 4 squared plus 3 times 4 minus 4. So you have 16 plus 12 minus 4. Okay, so 16 minus 4 is 12. So you can see this as 12 minus 12, which is 24 in total. Okay. Lastly, we have f of 1/2. This will involve fraction, obviously. So we have 1/2 squared plus 3 times 1/2 minus 4. So we'll have 1/4 here plus 3 over 2. And then I recognize that we're going to have to simplify this by adding these fractions. So I'm going to change this 4 to a 16 over 4, right? Because we need to have common denominators. So I have 1/4 plus 3 over 2. 3 over 2, we change this to 6 over 4. And then we have 16 over 4 here. So 1 plus 3 minus 16, that's 4 minus 16. Oh, sorry, looking at the wrong thing. 1 plus 6, 7. 7 minus 16 is -9. And -9 over 4, that'll be -2.25, or -2 1/4. Right. So those are your 4 answers for part 1, or question 1. -6, -4, 24, and -2.25. Okay. Before we move on to the next question, let me just read this reminder at the top here. To evaluate a function f of x at a value a means replacing each value of x in the function formula with the value of a. So what this is basically saying is, if you have a general variable, in this case a, rather than a number, all you have to do is replace each appearance of x, in this case of f of x, with that letter. Okay, so this will make sense when I jump to the question 3. Question 2, I'll leave that to you guys to solve on your own. But I did want to go over question 3. It's a little more complicated. All right, so actually let me start off with part D, right? Because this has to do with the hint that I just read. So g of a equals 1 minus a over 1 plus a. And that's all you can do, right? So all we did was replace we replaced x with a, I should say. And then you have 1 minus a over 1 plus a. That'll be your answer for part D. That's all you can do for that. Yeah, you can't simplify it, so just leave it like that. Okay, and then let me jump back to part A. So g of 2, same thing as question 1, just plug in wherever you see x, replace that with 2. Okay, so we have 1 minus 2 over 1 plus 2. We have negative 1/3 for part A. And then for part B, we have g of negative 2. So 1 minus negative 2 over 1 plus negative 2, which is 3 over negative 1, which is negative 3. Okay, so negative 3 is your answer for part B. Part C, I'm going to leave that to you guys, as well as part A. Okay, but let me jump to part E. So g of A minus 1. So this is not just one variable. I mean, it's technically, it's a line, right? A minus 1, you can see it as a line. So rather than having one term, we just have 2 terms. But no problem, we just replace x with a minus 1. So we have 1 minus parentheses a minus 1 in the numerator, and then 1 plus a minus 1 in the denominator. For the numerator, you have to distribute the negative, so we have 1 minus a plus 1. So we have 1 plus 1 is 2, 2 minus a in the numerator, right? And then in the denominator, we have 1 plus a minus 1. So 1 minus 1 is 0, and then a in the denominator. Okay. So 2 minus a over a is your final answer. And then you can also simplify that to 2 over a minus a over a, right? You can divide both terms in the numerator by the denominator if you have a single term in the denominator. So you have 2 over a minus a over a. A over a is 1, so you have 2 over a minus 1. But either answer is acceptable. Okay, so yeah, feel free to leave it like that. Okay, and then for question 4, please also complete that on your own. Quick question: is this mapping the function? Why or why not? Think about the grocery store example. Okay. All right, but yeah, that's all I wanted to say for today. And please remember to complete this classwork. The rest of the questions we'll go over in our synchronous session. And please also complete the homework and upload that to Google Classroom by tomorrow night. Okay? All right, hope you guys have a great rest of the day. I'll see you guys during our synchronous session. Take care.